Okay, we are back with section 3.1. We have already done a lot in this section. We have introduced imaginary numbers, defined the letter I, or the number I, to be the square root of 1. We've talked about complex numbers. We've added, subtracted, and multiplied complex numbers. So we're just going to build on that here and talk about the powers of I, because this makes an interesting, if you can find the pattern, then you can do things like calculate I to the 37th power without having to actually multiply that all out. So this is going to be a fun one to do. And then we'll get into division. Okay, so let's just look at all of these different powers of I. And let's just start with I squared. Well, I squared has already been defined. If you go back to page 1, the definition of I is that it is the square root of -1. Or another way of saying that is that I squared is what? -1. So we get -1 right here. Now to calculate I to the third, I like to remember that this is I squared times I one more time. We just calculated that I squared is -1. So we have -1 times I, which would be negative I. And I to the fourth is just I to the third, which is -I, times I one more time. I times I squared, and I squared is what? -1. So we have -1, or just 1. I'm going to circle my answers to make it a little easier to read here. Okay, let's go to the next row, or the next column. I to the fourth was 1. If we multiply that times I one more time, 1 times I is just I. I to the sixth, take I to the fifth, which is I, times I again, and we're going to get I squared, which is, by definition, -1. And then we have -1 times I again, -I times 1 again, or I again, so we get -I squared, which is +1. I squared is -1, so -I squared is 1. And let me circle those just to make sure that we're seeing them. Is anybody seeing a pattern here? Look at these two columns of numbers and look for a pattern. Do you see it? First row is I. I'm just going to follow the pattern. Second row is -1, and this is true. It will just keep repeating this pattern. And you don't have to memorize it. If you understood what we did there to develop it, that's what I would do, is I would just write out that first column. If I'm like, okay, wait a minute, I want to know, how does this pattern work? Just work through it. Okay, so how does that help us calculate something like I to the 37th? Well, if you notice, this pattern repeats every 4 powers. So I to the 4th looks just like I to the 5th through the 8th, looks just like I to the 9th through the 12th. Notice this bottom row down here. These are all multiples of 4. I'm going to put the power is. The power is a multiple of 4. 4, 8, 12. So wouldn't you guess that 4 to the 16th is also going to be 1? Or I to the 16th, I to the 20th, I to the, what else is a multiple? I to the 40th. That's a multiple of 4, right? It's going to be 1. Anything that's a multiple of 4 is going to be 1. So that's the first thing, is if you can divide it by 4 and it comes out even, it's going to be 1. Okay, what if it isn't? If it isn't, then you look at the remainder, and the remainder is going to, let me erase here to make a little room. Erase this stuff. Okay, and what you're going to do is you're going to look at the remainder after dividing by 4. And if it's 0, then that means it was divisible by 4. So it's going to be 1. And if it's 1, so the numbers up here that when you divide by 4 have a remainder of 1 are the 5 and the 9. And what are they? I. What if the remainder is 2? That would be our 2, 6, and 10. That would be -1. And if the remainder is 3, that's the same as 3. 7, 7. If you divide by 4, you have a remainder of 3. 11, divide by 4, it's 8 with a remainder of 3. Those are negative I. So this is how you determine something like I to the 37th. So let's take 37 and divide by 4. It goes in 9 times. Subtract 36, we have 1. So our remainder is 1. So we look over here at the chart, and it says if the remainder is 1, it is I. Okay, what about 52? Divide by 4. Oops, it comes out even. There is no remainder. So it's going to be like the 4, 8, 12, and it's going to just be 1. Pretty cool, huh? So again, I am not big on memory work. If you want to memorize this over here, let me put a box around it. If you want to memorize this, go for it. But myself personally, I'm always afraid that if I memorize something like that, I'm going to just get something turned around when I'm taking a quiz or taking a test, and I'm going to miss problems because I memorized it, but then I got confused. So what I would recommend instead of memorizing, although again, you're welcome, different people, just the way we learn and the way that we remember things is different. But what I would do is I would, in my margin of my quiz, I would just develop these. And this is going to be the remainder 1, 2, 3, and 0. So write out I is just I squared is -1, I cubed, work through it to get negative I to the 4th is 1, and then that will remind you if the remainder is 0, it's the same as I to the 4th, which is 1, and so on. Okay, let's look at division. So before we do division, we need to define conjugates. And you'll understand why when we get to the division. But conjugates are two complex numbers that the only difference is the sign on the imaginary part. It's this sign right here. A plus BI and A minus BI are conjugates. The thing that is cool about them is whenever you multiply conjugates, so 7 plus 2i and 7 minus 2i, that's conjugates because the only difference is the negative and the positive 2i, that you actually get rid of the imaginary number, and I'll show you why. So let's just multiply this out. Again, it's treat it like a binomial times binomial, so we're going to do FOIL. 7 times 7 is 49. Outside is 7 times -2, which is 14i. 2i times 14 is positive. 2i times 7 is positive 14i, and then last times last is 2i times -2i. I got ahead of myself. Let me make that a negative. So 2i times -2i is -2i squared. And then we need to do some simplifying. Couple things we can do. We can combine our i's, so -14 and positive 14, and what do you get? They actually go away. Positive plus a negative of the same thing. So then we're left with the 49 minus 2i squared. Remember, I squared is equal to what? -1. So 49 minus 2 times -1, we multiply that out, we get 49 plus 2, which is 51. Okay, I just realized the mistake. You guys probably caught me. You're probably like, what is she doing? 2i times 2i is 4i squared. So that carries all the way through. And so we get 49 plus 4. Okay, plus 4 equals 53. That's our answer. Okay, let's do another one for practice. First times first is 9. Now, if you're sure it's conjugates, it has to be exactly the same, but that middle sign is different. If these are conjugates, true conjugates, the only difference is the sign on the imaginary part. You can skip the O and the I because we know they're going to cancel out just like they did up here. One of them is going to be a positive 15i, one of them is a negative 15i. Those cancel out. You can go straight to the last times last. And then it's going to be negative 5 times 5 is 25, but then you have I times I, which is I squared. What does that do? That changes the sign. And so we get 34. Now, why are we doing this? Why on earth are we doing this? Why would we want to multiply two conjugates together? And the reason is that it allows us to get rid of the I in the denominator. We do something similar whenever we are dividing binomials that have square roots in them. We kind of don't like to have that stuff in the denominator. So if I want to get rid of my I in the denominator, I can multiply by the conjugate of the denominator. So it's exactly the same thing except for the sign in the middle. And I multiply both the numerator and denominator by that. And the reason that we can do that is because if you have a fraction that has the same thing on the top as it does on the bottom, then it's basically equal to 1. So we're multiplying by 1, but we're going to change how this fraction looks. So in the bottom, we're multiplying conjugates. So first times first is 9. And we can skip the O and the I because they are conjugates. We know those are going to cancel out. We get negative 5 times positive 5i, which is negative 25i squared. Numerator, 2 times 3. Outside is positive 10i. Inside is 3i. Last times last. Okay, now we need to simplify. So first thing I want to do is I want to get rid of my I squares. I squared is negative 1, so that makes that a negative 5, and it makes this a positive 25. Okay, now I can combine like terms. In the numerator, I have 6 minus 5, which is 1. And for the i's, I have 10i plus 3i, which is 13i. And in the denominator, 9 plus 25 is 34. And let's do one more for practice. Again, I'm going to multiply by the conjugate of the denominator, and I'm doing it both in the numerator and denominator. First times first is 6 on top, minus 6i. Inside is 2i. Last times last is negative 2i squared. And in the denominator, these are conjugates, so I only have to do F and L. I don't have to do the inside and outside. 1 times 1, and I times negative I is negative I squared. Change colors. Our I squareds become negative 1, so that makes that a plus 1. Makes it a plus 2. 6 plus 2 is 8. Negative 6i, positive 2i is negative 4i. In the denominator, 1 plus 1 is 2. And this one we can actually simplify because everything is divisible by 2. I can divide everything by 2. And I get 4 minus 2i. Okay, that is the end of section 3.1.